In this video, we're going to look at naming covalent compounds, and it's binary covalent compounds, ones where you have one type of, actually, where you have only two types of elements. Okay, you might have more atoms, but you only have two types of elements, and those are relatively easy to name, and that's what we're going to work with. Okay, here are some rules. Elements are usually written in order of increasing groups. So what that means is carbon is more in the middle of the periodic table, oxygen is more on the end. Carbon's in family 4, oxygen's in family 6, nitrogen's in family 5, oxygen's in family 6. So the lower family number usually comes first, with the exception of hydrogen. Okay, full name of the first element and the second name gets the "ide" ending. Probably sounds familiar to when we did covalent things. And then we're going to put prefixes on elements to tell how many of an atom we have. So we could, with ionic, know charges and then figure out the ratio of things. But for covalent ones, we're just looking at molecules and telling you how many particles are in each molecule. So it's not really based on charge things. You're combining two things that both gain electrons by sharing. And the first molecule we're going to look at is CO2. So I'm just going to give you a visual of this. If you look up by me, it's a black carbon with two red oxygens, and they are actually both double bonded to each other. And to name this, I'm going to go to, let me grab this, and the first name is going to be carbon. I just used the typical name. Now, why don't I put a prefix mono on the first one? I use mono on last names, but I don't use it on the first names. Otherwise, if we looked up things, you see a lot of things that would be mono, 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 mono. It'd be a lot of monos. So we ignore the mono when it's on the first name. Or on the second name, we don't. Now, the next name, instead of oxygen, it's going to be oxide. And we have two of them, so we're going to call it dioxide. D-I-O-X-I-D-E. So that would be carbon dioxide. Okay, let's do another one. And I'm going to grab this and put it down here. And let's do this. Oh, there's an N, which is nitrogen, but there's two of them. So I'm going to say dinitrogen. Notice I don't do any ides on the first name. And then there's two oxygens. So we're going to say dioxide, just like we did last time. And nitrogen's oxygen's kind of interesting because there's all different combinations of nitrogen oxygen that you can get depending on the way you put it together covalently. So there's a lot more options for possible things than with the ionic substances, but we just name them based on what we see. Okay, sulfur, I should say sulfur hexafluoride. If you breathe in helium, you get a high squeaky voice. If you breathe in sulfur hexafluoride, because it's so heavy, you get a very deep voice. So that's what we have here. I'm going to go and write this name here, and I'm going to call this S for sulfur. Notice there's no di's or tris, so it's just S. And then it is fluorine, or fluoride comes from fluorine, which is F, and there's hexa, which is 6, so it's SF6 right here. And then this last one is boron, which is a B. And there's penta, which is 5. And again, you have these rules in front of you. You can look at those. They're right here. They're also on the back of your common ion table. Or actually, I think there's a separate document with that naming rules in Schoology for you. So you have the naming rules for all the different things, including the covalent ones with the prefixes. Okay, so we got this H, and then I'm going to put a 9 right here. So what is this? Pentaboron means 5 borons. Hydride is from hydrogen. And nona, what's that? Oh, it's 9 is nona. That might not be that familiar to you, but it's B5H9. So that's just a little bit with the naming. Maybe we'll go to the other sheet and just do one more example of either formula to name or name to formula. But something to note here, if you start seeing dis and tris and tetras and things, you know it's a covalent substance because the ionic ones don't have that. Okay, so that helps you identify what it is. Okay, another thing is, with the exception of ammonium, if you start with a metal, you're going to have an ionic substance. But all these start with a non-metal, so right there you're thinking of a covalent thing, because ultimately we're going to mix up the covalent and ionic. We're not there quite yet. Okay, let's do a little clear my drawings. We're going to go to the next page, and I'm going to do name the following molecules or determine the formula. So I'm going to go to this one, CO, and I'm going to come up with a name of it. And the first name is, let's see, trying to get a text there. Oh, I think I got to do this. Sorry. We're going to call it carbon. And that one is going to be carbon. And then I am going to say monoxide. So it gets the "ide" ending, and we do want to put the mono on the second one. Now, why do you need to do that? When I see a mono or dis or tris, right away I'm thinking it's covalent. So that'll tip me off it's a covalent molecule, but we only put the monos on the second name. Now, looking at this, that's a lot of O's in the middle. It looks like carbon monoxide. Okay, so we don't want to sound like a cow when we do this. We're not going to say carbon monoxide. We're going to call this carbon monoxide. Okay, and that's what we have here. And this was carbon. Let's see if there's a molecule of this. This is a carbon, and this will be an oxygen in blue, and it's actually a triple bonded, pretty unstable molecule, and gets in your system, can do pretty nasty things by really attaching to the hemoglobin in your blood and not starving your body of oxygen in a pretty short amount of time. Okay, well, that's not such a happy thought. So let's go to one more thing here, and I'm going to go down here to this one, and I'm going to do nitrogen trihydride. Now, there's a common name for this, which is ammonia, but it's going to be nitrogen. I'm going to do a little draw function here. There's no mono in there, so there's just an N. And then hydride is for element hydrogen. And there's tri, so there's three of them. So I'm going to call this NH3. Now, a more common name for nitrogen trihydride is ammonia, but it looks like this structure right here, an N with three hydrogens attached. All right, I'm going to just leave this for a second and scroll onward. And if you go to the next page, it's really just more of the same in a column. Formula to name or name to formula, and just practicing this. And then there's a key that you can check over most of your answers to make sure you have this down. So hopefully that helps with naming binary molecular compounds. And those are the only covalent ones we are going to be naming as you complete your worksheet here. All right, thanks for joining in.